In this next video, we are going to learn all about congruent angles and angle bisectors. Now, if you remember in the first video when we went over points, lines, and planes, you can see a piece of paper could represent a plane. The surface is the plane. And if I were to draw an angle on this plane, you can see that the plane is divided up into three separate parts. There are points that fall on the line or on the angle. There are points that fall within the angle, known as interior points. And there are points that fall outside of the angle. These points are known as exterior points. So we have our interior points inside the angle, X, Y, Z. We have our exterior points, which fall outside of the angle. And we have our points that fall on the line. So interior, exterior, and points on. Now, if you remember from a previous video, we said that congruent segments are segments with the same measurement. Just how you can have congruent segments, you can also have congruent angles. Let's find the measure of ABD first. The measure of ABD is 40 degrees. So the measure of this angle is 40. Now let's look at the measure of the angle EBC. The measure of angle EBC also falls on 40 degrees. "40 degrees is equivalent to 40 degrees, therefore the angle of ABD is congruent to the angle of EBC. We use the same symbol and we say angle ABD is congruent to, same congruent symbol for a line segment, angle EBC. And just like you can use a tick mark to show that lines are congruent, you can also put a tick mark to show that the angles are congruent. Now, knowing what interior points are and knowing what congruent angles are, we're going to look at what an angle bisector is. So in order for a ray to be an angle bisector, it must have both of the following. One, the end point of the ray must be an interior point of the divided angle. What this is saying is if I was to divide this angle, let's call this A, B, and C. When I divide it with this ray, BY, then the end point of that ray, BY, is an interior point of the angle ABC, the original angle, or the divided angle. So ABC is divided with the ray BY, and Y is interior to ABC. So this first one is true for this picture. And in this case, the endpoint we are referring to is not the vertex B, but the point Y. So really, any other point extending out on that ray could be considered the endpoint. and 2, the angles created by the bisector are congruent. So if BY is our angle bisector, then ABY needs to be congruent to YBC. Let's take this example and blow it up so you can see the measurements. So here we can see that the measure of angle ABC is 140 degrees. So the measure of angle ABC is 140 degrees. Now remember, there were two constituents to the angle bisector. One, the end point of the bisector has to be inside of ABC, so it cannot go on the outside somewhere over here. So it has to be an interior point. Also, the new angle, AB, whatever the point is, let's just say Y again, the new angle ABY must be congruent to the other angle that the bisector created, YBC. Looking at this, for two angles to be congruent, they have to be the same measurement. Thinking about this mathematically, that would mean that this angle ABY being congruent to YBC are the same number. So you would double one of those to get 140, or 140 divided by 2. We know 140 divided by 2 is 70. So let's double check that ABY is equal to 70 and YBC equals 70. So the measure of angle ABY is equal to 70 degrees, and the measure of YBC is also 70 degrees. Therefore, BY is an angle bisector. That's because 1, Y, the end point of this ray, is an interior point to the angle ABC, and ABY is congruent to YBC. After this video, you should have a good understanding of interior and exterior points, what makes two angles congruent, and how a ray becomes an angle bisector, or how to figure out if a ray is an angle bisector.